Okay, guys, I want you to be familiar with something I'm about to say. Asymptote, asymptote, 1, 2, 3. Asymptote, asymptote, 1, 2, 3. We are going to be graphing some tangent and cotangent graphs now. And the good news is, then we've graphed all 6 of them, and we are done graphing. But then we have to practice so that we can nail it. So, y equals tangent x. Well, this thing right here, this guy's a 1. They didn't write it in. I'm not going to either. This thing right here is a 1. They didn't write it in. I'm not going to either. But that would be my bx. See, here's how tangent works. Tangent functions have 2 asymptotes. So you take whatever the b value is, bx, and you set it equal to negative pi halves. And then you say bx, whatever the b value is. I heard my voice crack, yeah. And set it equal to positive pi over 2. Now, lucky for me, it's a 1x. If it was a 2x or a half x or whatever, I'd have to get x by itself. But 1x, well, guess what? This is what I call my first asymptote. So that's my first asymptote. That's my second asymptote. And those are going to be my boundaries for this graph. Check it out. It always goes like this. When it comes to a regular old tangent graph, come on, really? Okay. I'm not going to mess with that. Come on. There you go. So I'm just going to sketch it out real fast here. I'm going to go like this. Here's my first asymptote. Here's my second asymptote. Okay, here's my first asymptote. Here's my second asymptote. Asymptote, asymptote. 1, 2, 3. There should be 3 locations between your 2 asymptotes. There should be 3 locations. And here's how it's going to look. I'm getting rid of my 1, 2, 3. But I am going to mark my first asymptote, negative pi halves, down here. Here's my other one, pi halves. Now, the thing is, the period for tangent is different than all the other guys. When you want to know what the period for tangent is, you take the bigger asymptote, in this case, pi over 2, minus the tinier asymptote, okay? A minus is a plus, so what do you get? 2 pi halves. Well, 2 pi halves is the same as pi. This represents our period. The distance between the 2 asymptotes is our period. And then you take that number times 1/4. And you get your, guess what? Increments, just like we did with everything else. I'm going to just say increms. So, let's take a look at this. Of course, this has got to be 0 in the middle. And if I'm going to be counting by quarters, right, this would be 1 pi fourth. This would be 2 pi fourths. It would be 2 pi fourths, but I reduce it. I call it pi over 2. This would be negative pi fourths. This would be negative 2 pi fourths, but I would have reduced it. So what I'm trying to get at is this. Tangent gets graphed in its own unique way. Tangent will repeat infinitely, but it's not a wave function like sine and cosine. It's got asymptotes breaking it up down the number line. So here's what a standard tangent graph looks like. Let me draw it in red. I'm going to stick with my theme here. My theme is going to be all my markings in black, my asymptotes will be blue, my graphs will be red. So if you want to follow along. So right dead center, boom, there's my guy. I go up 1 unit, there's that guy. I go down 1 unit, there's this guy. And here's what a tangent graph looks like. Remember, the blue lines are asymptotes. So this graph is going to exist between the asymptotes, and it always has that cool curvature look to it. Now, on the very first part of the assignment you guys are going to do, they're going to ask you for one period only. This right here represents one period. Now, if they ask you for 2 periods of the function, here's my advice. I'm gonna erase some of this stuff so it's out of my way, and I'm gonna extend this, and I'm gonna give you guys another period of this. But here's my advice. I'm gonna grab my black pen, and I'm gonna go, okay, I have an asymptote. 1, 2, 3. I would have another asymptote here. So I'm gonna grab my blue pen, I'm gonna draw that in. Because every time I sketch a tangent, it is always easiest to sketch one perfect period of it and then go back and extend it. So here we go. I was counting by quarters. I left off at pi over 2. That's 2 pi fourths. So this would be 3 pi fourths. This would be 4 pi fourths. I can come back and reduce that. That would be 5 pi fourths. That would be 6 pi fourths. So what I'm trying to get at is I can just count straight down the number line. I can then go back and say, you know what, 3 pi quarters, that's cool, but 4 pi fourths, I should just call that pi, and 6 pi fourths, I should rewrite that as 3 pi halves because that would be reduced fractions. But here's the thing. Asymptote, asymptote, 1, 2, 3. There's the middle dot, there's the upper dot, there's the lower dot. And this guy right here should be congruent or the exact same shape as my first graph. That would be 2 periods of this function. So, like I said, in the very beginning, they're going to just ask you to graph 1 period, then they'll extend it to 2, but it's always easiest. Get 1 completely done, and then come back and do the second one, because then you're just extending it. All right, now let me go through one more tangent graph, because once you got the rhythm of tangent, it stays the same. And then cotangent is similar but not the same. So since these are the only functions that are like this, tangent and cotangent, I waited and did these at the end because all the other graphs, if you can graph sine, you can graph cosecant. If you can graph, let's do this. We're going to do 1 plus 2 tangent 1/2 x. If you can graph, sine, you can graph cosecant. You can graph cosine, you can graph secant. But tangent and cotangent are the only ones you're going to hear me say asymptote, asymptote, 1, 2, 3. So, guess what this represents? That is a vertical shift. So I'm going to go up 1. Now, this is an amplifier. This is an amplifier, but a tangent graph goes infinitely high and infinitely low. So in our book, they don't refer to it as an amplitude of 2. They refer to this as a stretch. We're going to kind of like stretch it like a piece of taffy and make that graph skinnier and longer. This guy is my B, so it's BX. So I go BX equals negative pi halves. And then I go BX equals regular pi halves. What am I doing this for? This is how I find my first asymptote. This is how I find my second asymptote. This is always, always what we do. There's my B value. So it's BX equal negative pi halves, BX equal pi halves. And then over here I would say, you know what, I want to solve this. I'm going to multiply this side by 2 and this side by 2. Bam. I'm going to multiply. I would do the same thing to both of these guys. And my first asymptote is at negative pi. Then my second asymptote is at regular pi. My graph is the information between the two asymptotes. My graph is the information between asymptote 1 and asymptote 2. So here we go. I am going to sketch this graph. But before I do, I need to know the period. The period is the distance between the two asymptotes. So always take the bigger asymptote minus the smaller asymptote. That's the easiest way. So this thing has a period of 2 pi. 2 pi would be the period of this function. If I take that number and I multiply it by the magic number 1/4, boom, boom, pi over 2 increments. That's my counting pieces. Alrighty. So I'm going to start at 0, and I'm going to go this way. I'm going to go 1 pi half, right, pi over 2, 2 pi halves. But of course I wouldn't say 2 pi halves. I would reduce that. I would say that's the same thing as saying pi. Then I would go over here. I go negative pi halves, negative 2 pi halves. See, I'm just counting. But of course we wouldn't do that. We would just say negative pi. And then let's draw in those asymptotes. I'm going to use blue for all my asymptotes. So it's asymptote, asymptote, 1, 2, 3. There's 3 locations in the middle. That's what it is. Now, when I do my markings on the y-axis, remember this thing has a vertical shift. It went up 1 unit. It went up 1 unit. That's going to be my center line. That is my center line. Then I was stretched, so I'm going to go 1, 2 units above it. I'm going to go 1, 2 units below it. So at negative 1, I'm going to have my lower dot, and at positive 3, I'm going to have my upper dot. Now, I'm going to sketch this graph, and I have not flipped it. I haven't flipped it. So it always goes like this. Center dot, and then there's one up on the right, there's one down on the left. That's what this graph is going to look like. There's my 2 units. That's my stretch, just so you can see. That's where I stretched this graph. And over here on this side, that's where I stretched it down. Stretch. So I'm counting down to negative 1 there. I'm counting up to 3 there. That's my 2 unit stretch. Of course, that's my center line, right? But here's my graph. It's asymptotic. It cuts through those dots. It goes like that. That would be 1 period of this graph. So like I said, they're going to start you out, you're only graphing 1 period, then they're going to come back at you and say, sketch another period. So let me get this out of the way, and I'm going to just keep my same pattern here. I'm going to use black for my thing. So I would say, if I were to mark this off, I'd say 3 pi halves, 4 pi halves, let's reduce it, 5 pi halves. And I need one more dash, that would be 6 pi halves, I'd call that 3 pi, right? And I would then be able to sketch in another asymptote. Come on, blue. And yeah, I'm running out of room on this pad, but that's what I got. And let's get this extended a little bit here. Okay. And if I were to sketch another period, in the middle, right, because it's asymptote, asymptote, 1, 2, 3, there'd be my low dot, there'd be my high dot, and once again, when I sketch a tangent, it's got that curvature to it. I missed my middle here. I'll make the dot real big, and then it looks like I hit the dot in the middle. But that would be 2 periods of tangent. Be careful. When you guys do take the test at the end of this journey here, On some of the graphs, I'm going to say 1 period only, and then on some, I'm going to ask you for 2 periods. Knowing when a graph is starting and stopping is important. Knowing a period is part of what I'm looking for. So be cautious when it says that in the instructions. Alrighty, let's take a look at cotangent, because cotangent is actually a little bit easier than tangent. Let's talk about it. So, you got the idea that I can do, I'm going to, you know what, I'm going to shift this cotangent up. Because I know you guys have played around now with quite a few of these graphing concepts, that I'm just going to show you how cotangent looks, but I'm also going to incorporate, hey, guess what, I could move this thing up 2 units right away. That's a vertical thing. But I am not going to stretch it or anything like that. There's no stretching here. It's a 1. And then here we go, bx. So bx does not equal negative pi over 2. It equals 0. bx does not equal regular pi over 2. It equals pi. Here's where cotangent and tangent are different. To find the asymptotes for cotangent, you take whatever this part is, you set it equal to 0, you set it equal to pi. This will produce for you, well, 1x equals 0. That means your first asymptote for this guy is at 0. Then 1x equal pi, well, that means your second asymptote for this one is at pi. So take the bigger number minus the smaller number, you get the period. So it's not actually that bad. Cotangent's pretty quick. And then, of course, I would take pi times the magic number 1/4, which breaks my graph into quartiles, and it also tells me the size of my increments. This one's going to be a piece of cake. Watch. Let's graph this thing. Here's my y-axis. Here is my x-axis. Whoop, I'm going to extend it. I didn't put anything on the negative side here, because you know what? I don't need anything on the negative side. This thing has a mark at 0. Then it's going to go 1 pi fourth, 2 pi fourths, 3 pi fourths, 4 pi fourths. I know I can go back and reduce 2 of these. But that would indeed, without a doubt, give me an asymptote 1, 2, 3. Let me reduce this stuff first. I'm going to go back and say 2 pi fourths. No. I'm going to call you, what? Pi over 2. And then 4 pi fourths. No. I'm going to just call you pi. Or 1 pi. Let's draw in some asymptotes. Asymptote. Asymptote. 1, 2, 3 locations. Asymptote, 1, 2, 3. Okay, I'm going to get rid of those 3 locations, but that's what I mean by asymptote, 1, 2, 3. You always have 3 dots in the middle. I'm going to grab my black pen again, and I'm going to say, you know what? This cotangent was shifted up 2 units. But I'm going to go 1 unit above it, 1 unit below it. That's what I'm going to do, because that's what cotangent looks like when you don't amplify it or stretch it or anything. And guess what? Let's put some dots on some spots. A cotangent graph will start on the center line. Oh, I never marked my center line. Here, you know what? I'll do it in red. That is my center line. Boom. Right on the center line, right in the middle. That's where that dot goes. Now, on a tangent, I would put a dot here and I'd put a dot here. If it was a tangent, that's what I would do. But cotangent is the reciprocal. So, check this out. Boom, boom, getting rid of those dots. One of them goes here, up on the left, down on the right. So a cotangent graph actually looks like a flipped tangent graph. A cotangent graph looks like a flipped tangent graph. That's what it looks like. So once again, how do you graph a cotangent? It's very similar to tangent, but the formula is a little different. You say bx equals 0, bx equal pi. You do not say bx equal negative pi over 2, bx equal regular pi over 2. You don't do that. That's for tangent. bx, right? Here, my b was a 1, so bx equals 0. bx equal pi. That's what we do to find the asymptotes for a cotangent. And always, 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 it is asymptote, asymptote, 1, 2, 3. That's how we graph these things. Let me get that goop out of the way, because I'm going to extend this for one more period for you. So I'm going to go grab my black pen and mark it off. So I have an asymptote already. So 1, 2, 3. That's going to be my other asymptote. Now I just have to count. So I left off at 4 pi fourths. This would be 5 pi fourths. 6 pi fourths. 7 pi fourths. 8 pi fourths. So think about it. I'm going to reduce this one. 6 pi fourths. I'm going to call it 3 pi halves. 7 pi fourths, I'm going to leave alone. 8 pi fourths is 2 pi. And I'm going to grab my blue pen. I'm going to put my asymptote there. So if they asked me in the homework for 1 period, I would have already been done. But if they ask me for 2 periods, I go back and I do asymptote, asymptote, 1, 2, 3. And I would sketch this curve so that it looks congruent to the other one. Congruent in this case means the exact same shape. I can see it's a little bit off, but I would give that to you. That's full credit in my book. I got one last problem I want to show you for cotangent, and then we'll talk about horizontal or phase shifting in the next video. So here we go. We got one more, because I want to make sure that you see something like this, where you have something like y equals. Now, I'm not going to put a vertical shift in it. I'm not. But I haven't flipped anything yet, and I'm going to wait a minute. Sorry. I was going to put a fractional value here, and here I'm going to put a whole number value. Okay. So this graph has not been vertically shifted, but it is going to get flipped. So think about it. I'm going to scroll up for one quick second. When you flip a cotangent, it's going to look like a tangent. When you flip a cotangent, it's going to look like a tangent. This, in our book, is called a shrink. When you have a fractional, 1/2, 1/4, whatever, it's going to compress your graph. It's a shrink, not a stretch. But here we go. Here's my bx. So I'm going to say bx equals 0, bx equal pi. If I divide both of these by 2, I still have 0. What is this guy? He's asymptote 1. If I divide this by 2 and divide this by 2, I get x equal pi over 2. That guy is my second asymptote. So my graph is going to be all the information between those two asymptotes. Now, I haven't done this yet, but I want you to see that you can actually sketch this graph without labeling any of this junk for me. If you get the concept of how to graph it, watch. I know that this asymptote, first asymptote, is at 0. So I am not going to give myself a ton of room on the negative side of the x-axis. All of my information is going to be focused on this side, okay? And I have not been shifted up or down, so this graph's going to start on the line 0, right? But I have, technically that's going to be an asymptote. 1, 2, 3, that's going to be my second asymptote. I want to keep my color scheme the same. So all my asymptotes are blue, just to color code it for you. Asymptote, asymptote, 1, 2, 3. Well, if this is, let's say, 1 unit, then that would be a half a unit. If this is, let's say, negative 1 unit, that would be a negative half unit, right? That's what that shrink is about. Check it out. I'm going to put a dot here. And I normally, for a cotangent, would put the dot here and the dot here. I would, because they told me to shrink it. But what did they also tell me to do? They told me to flip it. So I'd go, ooh, wait a minute. If you flip a cotangent, it looks like a tangent. So here's my graph. Ooh, I missed that dot a little bit. I'll make it a little bigger. That's my graph. I was able to sketch that graph without telling you anything because every tangent in every cotangent graph follows the same pattern. Asymptote, asymptote, 1, 2, 3. If you know where the two asymptotes are, you can do it. But the one thing that'll cost you a lot of points on the test, though, because I need to know what your quartile markings represent. But not too tough. Not too tough. Remember, this one started at 0. It ended at pi over 2. And if I take the bigger asymptote minus the smaller asymptote, that's how the period is. The period is pi over 2. I take that times 1/4, which gives me my quartile increments, which is pi over 8 increments. And I'm counting by eighths. So this guy right here, this guy would have been pi eighths. Then 2 pi eighths. Well, that's just pi over 4. Then 3 pi eighths. And then this would be 4 pi eighths. Well, 4 pi eighths reduces to pi over 2. It certainly do. And all my stuff's knocked out now. If they asked me for one period of this picture, I would be done right now. But if they wanted me to extend it, I could do that easily. I left off at 4 pi eighths. This would be 5 pi eighths. This would be 6 pi eighths, but I'm reducing it. This would be 7 pi eighths. This would be 8 pi eighths, which would put me at pi. I'd grab a blue pen and I'd say that must be another asymptote because the pattern is always the same. Asymptote, asymptote. 3 marks in the middle. 1, 2, 3. Asymptote, asymptote. 1, 2, 3 marks in the middle. Let's make those marks. So this would be the center. That would be a half a unit up, half a unit down. And I would sketch this graph so that it looks like the other one. There you go. All right. So just keep in mind, tangent and cotangent are the only ones that are like this, where you take whatever the bx value is and you set it equal to 0 and pi if it's a cotangent graph. You set bx equal to negative pi halves and regular pi halves if it's a tangent graph. But everything else that you've learned is the same stuff. You can shift graphs up. You can shift them down. You can, amplify them. In this case, they call it stretching or shrinking. You can flip them. You can actually phase shift these things. Guess what? When you phase shift them, what you're really doing is you're going to be scooting the asymptotes sideways. But it's still going to be the same pattern. Asymptote, asymptote, 1, 2, 3. Now, the next video, I go through horizontal shifting. I do the phase shifts in the next video. So this video is concluded. Please go to the next video where you will find all the work and the answer key. Okay, catch you later.